So in earlier video, what we saw was we wrote a program which was using a file for communication purpose, which was a shared file. And then we tried printing the contents, okay, from the file. So we saw that there was no proper synchronization happening because it was printing, say, the lines, but the lines printed are not in the order that we were expecting. Now, if we want to achieve this goal, probably we can think of using some other alternative, and that's what we would be discussing in this session. So we'll be talking mainly about now writing the similar code, okay, which will be kind of created with help of the pipes. Okay, so we will make use of a system called pipe, okay, which is used for creating the pipe. And now what we'll be doing is, like when we created child, or when we created two childrens, we will have, say, different pipes created for the processes like PID1 and PID2. Say these are the two processes, then we'll be creating two different pipes for each of them. So they would be used for probably like as an writing end or reading end of a pipe. Fine. So let us use this. So what I will do, I will copy that code which we wrote earlier. You see, using file. So we'll copy this IPC using file.c to we'll create using pipe now. And now we will use this and we will try to modify this code. Okay. Now I will be letting you know what I'm going to keep and what I'm going to remove. So this is the same file that we used earlier, okay, to work out the things. Now we'll make some small modifications here. So we'll keep this as it is. Okay. We have to rewrite this code. Okay. So we have to rewrite this one. So I will delete probably from here. Okay. From here, we'll delete everything from that function. Fine. And then, like, it's not only about deleting contents from here. So we created now earlier the two process IDs. So we'll keep them as it is. Fine. Now, what I'll be doing is I'll be creating pipes for synchronization. So I'm using here pipes to get it synchronized. Now we saw that like what are the output that I showed you before a while with respect to the code that we wrote earlier. Correct. It was not printing in the synchronized way. Correct. So there should have been a proper communication that now process one is printing, then process two is printing, and so on. But it was like sometimes we saw that process one was printing, sometimes we saw suddenly again process one came and displayed the text and so on. So we'll create these two pipes here, okay, which would be of type integer because we will be using them for synchronization purposes. Now we will give call to both the pipes. So say pipe 1. So this would be for parent to child 1 to child 2 kind of. Okay. Pipe 1 and then child 2 to child 1 we have to create another pipe. Pipe 2. And so this is our pipe creation uh, thing that happened here. Now what we'll do is we'll create say first child process. Okay. Now if it is equal to 0, then here we'll make modifications. PID1 if equal to 0 because we want to work with child 1. So what we'll do here is like we will try to see like let us first say close right end of pipe and then we'll close read end of pipe and then we'll try to read the lines from the pipe like from 1 to 2. So like we'll be writing a read line function. So first of all, let us close the pipe. So as we are taking it with this two, so ultimately there would be two, like what we saw was there would be two things. One would be for read, other one would be write. When you say two, correct? So they would be referred as 0 and 1. So one 0 is meant for, as we stated earlier, 0 is meant for read, and 1 is meant for write. So now we have to close the right end of pipe 1, correct? So pipe 1, it should have been written as close pipe 1. So this is pipe 1's right end we are closing. Similarly, we will close read end of pipe 2. I will mention it in comment so that it would be easy for us to understand. So here what we are doing, we are closing right end of pipe 1. And alternatively, what we are doing is here we are close read end of pipe 2, correct? Now, so here now we have to give call to that my read. Now with my read, what we will be doing is, now as we are using file descriptor, correct? So with reference to the or like what you can call it as the pipes, correct? So what we will do is we will read from pipe 1 read, and we will write it to pipe 2. Okay. Now here what we are doing is we are trying to read odd lines and writing there, correct? So this would be for my read. So we'll be having three we can say parameters. Now this would be for second thing. So again we will have copy this code. We'll write it here. So we'll delete this line. Now here we have to make alternate changes. Now earlier what we did was we closed right end. Now we will close read end here, and then right end from here. So read end and right end. And similarly, the modifications are to be done with respect to this now. This pipe 2, 0, and now this one would be pipe 1. So we'll be printing here even lines. So as we stated in the earlier code, whenever it is 0, first parameter is 0, then ultimately we will say that we are going to read even lines, and this will be for odd lines. So we have to add semicolon. This would be for reading odd lines, and this would be for reading even lines. Fine. And now once it is done, so we have to close, and we have to display that too, like whatever is read by it. Okay, for every child. Now we have to close both the pipes. So close, because this would be parent process setup. We will require the parent process setup here. Fine. So I will let you know like why I'm doing this. Okay, after a while. So let us first write pipe 1, 0, close pipe 2, 1. Correct. Now, like what we'll do is we will have a round robin process. Round robin in the sense, say, process child 1 should do that, then it would be turn of child 2. Then again child 1, then child 2, then child 1, then child 2. So we want this kind of round robin thing. So let us create a signal so that that signal would be used to print it. Okay, so let us add that signal the way that we earlier added that x the signal, like saying that whether it is odd or even. So we want that round robin process for sending the first signal. So let us create a variable. So I will add one variable here, character signal. Okay. So here, what I will do is I will use some variable, say, okay, signal is equal to, say, let us add, say, Z. Okay, some signal there, which we will be using. Fine. And then we will write it, right? Okay. Now this writing would be for pipe 1. Pipe 1, the file descriptor given there. Then percent signal, we have to pass the value. So ampersand signal and number of characters. So we want this 1. Okay. And then appropriately we'll use this write, wait, and return 0. Now we have to work out with respect to this code. Now here, like we already added what we can call it as like file star file pointer, and we are using this file as gulam.txt, the one which we used there. And like I'm not really writing the code to verify whether the file is available or not. You can make use of if not file, or if fp equal to null, then error opening file kind of thing you can add, and then exit for exit failure signal. So now we already have written my line, which we are going to read with the length. Okay. Then further we will have line number, integer, because we have to store that line number. Okay. We are going to make use of this. So initial value would be 1. Now we'll start reading the file. So file while fget. Now you're like here, what exactly we are reading? So my line. Fine. Then size of my line. And lastly, the file pointer. So what is the file pointer that we used here? fp. Correct. So we are trying to read it. So till it is not null. When it is null or end of line, end of file, then it should start. So we have to wait for the signal to read. So whenever like we have to write that code. So let us write this. So if, correct. Now here, like with my read, we have to add the parameters. Now what they would be? So like we will have integer is odd. Then integer. So the file that we want to read empty, read file descriptor, and second would be write file descriptor. Okay, and this my read, like we have to write where. So let us see where exactly we wrote this. We want it here. This my read is that thing for process 1 and for process 2. Fine. So like we have to write the code now with respect to the condition. Like we want it to be covered with respect to the code. Fine. So let us work out it and let us see what happens. So if now we have to write the code such that we want to print we want to read the signal for read. Whenever read signal is available, then we will execute with the file descriptor and along with the process. So let us execute, let us write this. So if line number, okay, we want that line number, okay, mod 2, because we want whether it is even or odd. So if it is 1, that means odd, correct? And so it's odd. Okay, this would be there, or the way that we earlier wrote, or this would be what? 0, and this is not. Correct? Fine. Now here your if is done. Now we have to write if part. Like what should it do? Now it should start reading. So read. What is to be read? From where to read it? From the read file descriptor. Read underscore fd. What it should read? The signal. So we have created a signal variable. Okay. So that signal is to be taken. So where we are talking, where we are sending it, we'll see this. Okay. Signal. Okay. And then we want length to be 1. So we are sending X or Y kind of thing. We are going to work with it. So this is read. Now we have to print. So printf would be what? Process ID is equal to %d, comma, line %d is line %d colon %s. Now parameters would be get PID first. Okay. Then so get PID, then line number. Where exactly we are getting the line number then? So that would be with line number variable. Line underscore number. Okay, we want that line number and the line. Where exactly line is? So my line. Fine, this would be printed. Now, we want some break there. So let us add sleep there. Fine. And then we'll signal to the other process to write, read and write. So write FD, the file descriptor that we created. Okay. Write FD, the parameter that we passed, depending upon the pipe it is there using. So ampersand signal, fine, and 1. Now this if part is done and we have to just increase the line number. Line number plus plus. Now this would be completion of while statement. Now we have to close the file pointer. Okay, or the file descriptor that we are, and then simply say exit 0. So we are adding their sleep just to see, I will try to take it small number. Okay, let us say that this program should work. So let us try to compile. So GCC -m32. Okay, we'll work out. So we have to make corrections. I think I haven't added. Okay, double bracket is added. Okay, the signal part, let us see what is to be added there for signal. Fine. Because we are adding that as a variable. Okay, we added that variable. So that variable is to be added. So signal undeclared. Okay. So Emacs. We'll take this as global. Okay. So the function that we used. So we had my capital READ. So I think I wrote it small case. My read. Yes. Now let us execute this. So now you will see like it would be printing them in a similar manner, like the way that we were expecting as per the input file that is there. So that line contains serial numbers 1, 2, 3, 4. So serially they are added, like line 1, line 2, line 3, and we are trying to display it. Now you can see even one of the processes reading and other processes writing. Correct? Okay. So like if we see like what exactly is happening, whatever we added there, let us try to understand that one more time. Okay, from the code. So if I try to execute again that, and let us see what happens. Is it executing it in the similar order or not? Let us try to see that. And you will see probably here what is happening is it is going to take it the way the output was expected. Correct? In the similar order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Odd and even are separately printed. So one can see 5903 process is actually telling you or printing the odd lines, and 5904 is printing even lines. Now, what exactly we are doing here? We are forking two processes, one for odd lines, one for even lines, and we are using pipes for syncing, so that these two pipes will ensure that odd and even readers are alternate one by one, which are reading that. So, like for example, pipe 1 would be going from odd to even, and pipe 2 would be going from even to odd. And we are using a signal with a 1 byte character, okay, for control turn taking, like who should be there, kind of. So, like if you see here, like what exactly we did, we are using simultaneous file access there, one by one. Correct. Now, if we try to really check out the code, okay, so let us do this. Let us open that code. So we added these variables. Okay, this is we have taken as global. So we initially added header files. Okay, that they are meant for say std.h for printf scanf. Okay, stdlib for exit. Correct. Uni std for fork, pipe, read, write, sleep we used. Wait for wait.h is added for. So okay, we haven't added wait.h, but you can definitely add that. Okay. So but types.h would be used for PID underscore T. Correct. And that also can refer to wait function as well. Then FCNTL, because we want file control. We are not directly using it, but just for the sake, as I took the earlier code, that's why I added. So we have taken file name here, okay, as a constant name that we have given gulam.txt. Then maximum line length we have taken as 80 lines. Then we are writing this read line function. Here, the first is odd parameter would be telling us if the process reads odd numbered lines, then it would be 1. Okay. And if the process reads even number lines, then it would be 0. This is our assumption as the way that we had considered earlier. Read FD would be file descriptor for read synchronization signal. And write FD would be file descriptor to send signal to the other process. That's what we are using, because we want to switch from read to write to read kind of. Now inside this function, what we did was we opened the file here. Okay, we declared one variable, three variables here. Okay, say then we are reading this line. Correct. So if we see what is happening here, like when we are using these variables, ultimately, so we are exactly trying to achieve the goal in the sense of reading the values. Fine. So let us try to understand now through the while statement what exactly it is doing. So when we apply this function called while, actually what we are doing is we are trying to read the file line by line. So this function, sorry, this if statement would be checking if its process turn to handle the line, like whether it is odd or whether it is even. And then we are using this read system call. This would be for signal, like 1 byte from the other process. So that should pass some value. Yeah, now it's my turn is over. Now you can start, kind of. Okay, and then we are printing it, the process ID and details at whatever the one. Here I added sleep for 2 seconds so as to see the output. Fine. Then further, like what we did was we wrote, like we want to print. So that like whatever it is reading now, when it is reading, then I have to write that appropriately depending upon whatever the pipes that are passed as a parameter. While this myRead is called from respective child. Correct. Now in main function, what we did here below, we created two pipes. Okay. With PID, two PIDs. Pipe 1 would be used for signaling from odd to even, and pipe 2 would be used for even to odd. Okay, now in first child process, what we did was we forked the child, we are closing the unnecessary pipe end. So we closed that right end and read end, which are not important for us. And then we are reading odd lines by passing this one to my reader. Okay. And in the second child, similar code was there. So we explicitly closed unnecessary pipe ends, which we do not want. And then in my read, we are passing 0, which reads the even lines. Okay. Now in parent process, we are closing unused pipes, correct, which are not required for us. So that's why we ended this. Okay. Now what we have to do is we have to start the processes by sending the first signal to the odd line reader. And that's why we are writing this some value there. This will be signal that will be taken there as an a parameter. Okay. So when it writes, ultimately that signal would be sent to the pipe. Now start the other kind of thing. Fine. And this is how the code works. Fine. So if we try to check this again one more time. So GCC, now execute. So you can see that line 1, line 2. So if I go and really check this file, you can see, so the lines are properly taken, correct? So this is one of the best example to understand synchronization.